these equations for matrices are really no different from the other algebra you've done, except that you have to remember that we have not defined division for matrices. We don't have division for matrices. We have multiplication. So in order to do this, 2 times some unknown matrix is equal to some known matrix, we have to multiply both sides by 1/2. And remember, it's not commutative, so we have to do it from the left. We do it from the left because we want the 1/2 to cancel out with the 2, so that x will be equal to 1/2 times the matrix. And the matrix we have here is 20, -14, and 6. Okay, and so the answer here is 10, -7, and 3. And that would be this one. So the answer here is D. Same thing over here. We're going to have to multiply both sides by -1/2 here and here. And so x is going to be equal to 5 and -5 and -11 and +8. Okay, -1/2 times -10, -1/2 times 10, -1/2 times 22, and -1/2 times -16. So which one of these would be D again? Let's see what else. Okay. Here we have some subtraction going on. So in the interest of keeping things neat, let's add 4x to both sides. And then let's subtract the matrix from both sides. We'll get 4 is equal to, let's see, 28 and 8. Oops, I forgot my little x here. And then we'll multiply both sides by 1/4. Oops, it's not a fraction. And we get 7/2. 7/2. And this is 7/2 here. And so that becomes that. And let's see, the next one is already set up for us in a way. 4c is going to equal -31 minus 1, so that's -32. -5 minus -9, that becomes 4. And -20 minus -4, that becomes -16. We're going to multiply both sides by 1/4 and get -8, 1, and -4. And we're going to look for that over here and get A. Okay. Down here, this is write an augmented matrix for each system of linear equations, and the deal with an augmented matrix is simply that you want to take the coefficients of each one of the equations. So this would be -1, 5, -2, and over here, the right side of the equation, this would be -5, -4, 2, negative 16. This would be 0 because there's no x here. 1, negative 5, 17. So that's the augmented matrix. See if we can find that here. Oh, that's interesting. There's only one that has the right thing on the right-hand side. So let me just double check to make sure. Yeah, that's the right one. A. Okay. Sort of moving through these. Same thing here, write the linear system, or write the system of linear equations. So basically we're looking for a first line that has 3x minus 3y plus 4z equals negative 15. That's not this one. That's not this one. That's this one. And it's this one. Okay, so we've narrowed it down, right? So this one is no x plus y plus 5z equals negative 13. Okay. Plus y plus 5z equals negative 13, so that's okay. But this one's not. This is negative 9. I don't have any idea where that, whoops, here, I don't know, have any idea where that came from. So it can't be this one, so it's got to be this one. Okay, as long as these are multiple choice questions, you might just as well take advantage of the fact. The idea here is to make sure that you actually understand what it is that you're looking at. Here, you're looking for the reduced row echelon. Well, the left side is all in reduced row echelon form. The trick is to know what does that do to this side, and what it's supposed to do is give you the solutions to these problems. So let's just look quickly and see are 2 and negative 2 the solutions for x and y that work here. This would be 2 minus 5 times negative 2. That'd be 12, so this isn't it. This would be 3 minus 5 times negative 2. Right, that would work here. So these two have, oh, so these three have that. So we've only eliminated one so far. So let's move to this one here. If I put in 3 and negative 2 and 5, I get negative 15 plus 10 plus 25. That's not going to equal 0. So let me pick up from number 7, because the recording stopped and I didn't notice it, so you'll see I have done a little bit of this. I went through this first problem or this first answer and saw it couldn't be right. All of these answers are in row echelon, reduced row echelon form. So the real question is which one has the right answers. Remember, this is x, this is y, this is z. Those are supposed to be the solutions to this system of equations. So we took a look here and plugged in 2, negative 2, and 5. I actually just plugged them in first here because there were only 2 of them. So I plugged in 2 and negative 2, and that turned out to be 12 equals 13. So that couldn't be right. The rest of them all had the same. So I took 3 and negative 2 and plugged it in here. That became 3 minus negative 10, which is 13. So that actually worked. So then I decided I would plug these in somewhere else. So I took 3, negative 2, and 5 and plugged them into the first one. Got 12 plus 6 minus 5, 25, equaled negative 7. And that turned out to be right. So I got 2 of them. And just to check the third, I put it in here. I got negative 15 minus 10, which is negative 25, plus 5 times 5, which is 25, and that turned out to be 0. So B had to be the right answer. For number 8, you get the determinant of a 2 by 2 matrix by multiplying down this way and subtract the result of multiplying up this way. So 2 times 2 is or 2 times negative 2 was negative 4. 5 times 2 was 10, and if I subtract them, I get negative 14. Over here, it got a little more complicated. Okay, over here, I had to write down the 3 columns from this determinant of this matrix that we're trying to find the determinant of. Notice all it just says is this, but because the lines are straight, this has to be the determinant. It's not the matrix because that would have little brackets instead. Anyway, then I copied the next 2 columns over and multiplied down. 4 times 4 times 2 is 32, negative 12, negative 45. Added them together and got negative 25. Went the other way. That was 40. That was 24. That was 18. That made 82. Subtracted the 2, negative 25 minus 82, and got negative 107. And then I came over here and did the same thing over here. Copied this column, this column, this column here, and then copied these 2 again, here and here. Multiplied down this way, got 24. Multiplied down this way, got 30. Actually, multiplied this one down here, got 24. This one got 30. This one got negative 24. That equaled 30, added them together. And then I went this way, got negative 18, negative 12, negative 80, added up to negative 110. So I take this minus this, and I got 140. And that turned out to be one of the answers. And in fact, it turned out to be the right one. So looking at this for a minute, I can actually save some hassle here. If I multiply this matrix times this matrix, right? This is a 2 by 3 matrix here. This is a 3 by 2 matrix here. I know that I can multiply them together because the 3's are the same, and the result I'll get is a 2 by 2 matrix. So this becomes a 2 by 2 matrix. And I'm going to multiply that from the left by this matrix, which is 2 by 3. What's wrong with this picture? These numbers are not the same. I cannot multiply these. Okay, if I take 3 items from the first row and try to multiply it by the column over here, that's not going to work because there's only 2 things in the column here. So that's a problem. So actually this is undefined. Here, I put this one in because you have to know the procedure, but there's a lot of zeros, so that helps. In order to multiply these 2 together, it's 3 times negative 4, which is negative 12, plus negative 5 times negative 5, which is 25. And then for the next entry, we do 3 times 0 plus negative 5 times 0, so that's just going to be 0. And then we do 3 times negative 2, which is negative 6, negative 5 times negative 4, which is negative 20. Add them together, so it's negative 6 minus 20. This way I get negative 6 times negative 4, which is positive 24, and 1 times negative 5, which is negative 5. Again, here I get negative 6 times 0 plus 1 times 0, and that leaves me with 0. And then it's negative 6 times negative 2, which is 12, plus 1 times 4, which is 4. That becomes 13, 0, negative 26, 19, 0, 16. And I need to multiply that by this one. 0, 6, 0. So what does that become? Again, 13 times 0 is 0. 0 times 6 is 0. Negative 26 times 0 is 0. Add them all together for the entry in the first row, first column is 0. By the way, just double checking here. This is a 2 by 3 matrix. This here is a 3 by 1 matrix. So when I multiply them together, I should wind up with a 2 by 1 matrix. Let's see how that works. I did this. Now I have to do this. 19 times 0 is 0. 0 times 6 is 0. 16 times 0 is 0. Add them all up. That says 0. And I've run out of things to multiply and add together, which is what we would hope. I get a 2 by 1 matrix. And that 2 by 1 matrix is 0, 0, which I have here as answer A. So that is the solution to number 12. So now you got it all. And I hope you got them all right. And if you didn't, I hope you'll message me and we'll figure out why not. Thanks.